Texas Instruments Incorporated is an American company that designs and makes semiconductors, which it sells to electronics designers and manufacturers globally. Headquartered at Dallas, Texas, United States, TI is the third largest manufacturer of semiconductors worldwide after Intel and Samsung, the second largest supplier of chips for cellular handsets after Qualcomm, and the largest producer of digital signal processors and analog semiconductors, among a wide range of other semiconductor products, including calculators, microcontrollers and multi-core processors. Texas Instruments is among the top 20 semiconductor producing companies in the world. Texas Instruments was founded in 1951. It emerged after a reorganization of Geophysical service. This company manufactured equipment for use in the seismic industry as well as defense electronics. TI began research in transistors in the early 1950s and produced the world's first commercial silicon transistor. In 1954, Texas Instruments designed and manufactured the first transistor radio, and Jack Kilby invented the integrated circuit in 1958 while working at TI's Central Research Labs. The company produced the first integrated circuit-based computer for the U.S. Air Force in 1961. TI researched infrared technology in the late 1950s and later made radar systems as well as guidance and control systems for both missiles and bombs. The handheld calculator was introduced to the world by TI in 1967. In the 1970s and 80s the company focused on consumer electronics including digital clocks, watches, handheld calculators, home computers as well as various sensors. In 1997, its defense business was sold to Raytheon. In 2007, Texas Instruments was awarded the Manufacturer of the Year for Global Supply Chain Excellence by World Trade magazine. Texas Instruments is considered to be one of the most ethical companies in the world. After the acquisition of National Semiconductor in 2011, the company has a combined portfolio of nearly 45,000 analog products and customer design tools, making it the world's largest maker of analog technology components. In 2011, Texas Instruments ranked 175 in the Fortune 500. TI is made up of two main divisions, semiconductors and educational technology, of which semiconductor products account for approximately 96% of TI's revenue. History. Texas Instruments was founded by Cecil H. Green, J. Eric Johnson, Eugene McDermott, and Patrick E. Haggerty in 1951. McDermott was one of the original founders of Geophysical Service in 1930. McDermott, Green, and Johnson were GSI employees who purchased the company in 1941. In November 1945, Patrick Haggerty was hired as general manager of the Laboratory and Manufacturing Division. By 1951, the L&M Division, with its defense contracts, was growing faster than GSI's Geophysical division. The company was reorganized and initially renamed General Instruments Incorporated. Because there already existed a firm named General Instrument, the company was renamed Texas Instruments that same year. From 1956 to 1961, Fred Agnich of Dallas, later a Republican member of the Texas House of Representatives, was the Texas Instruments president. Geophysical Service, Incorporated, became a subsidiary of Texas Instruments. Early in 1988 most of GSI was sold to the Halliburton Company. Texas Instruments exists to create, make and market useful products and services to satisfy the needs of its customers throughout the world. Patrick Haggerty, Texas Instruments Statement of Purpose. Geophysical Service Incorporated. In 1930, J. Clarence Karcher and Eugene McDermott founded Geophysical Service, an early provider of seismic exploration services to the petroleum industry. In 1939 the company reorganized as Coronado Corporation, an oil company with Geophysical Service Incorporated, now as a subsidiary. On December 6, 1941, McDermott along with three other GSI employees, J. Eric Johnson, Cecil H. Green, and H. B. Peacock purchased GSI. During World War II, GSI expanded their services to include electronics for the U.S. Army, Signal Corps, and the U.S. Navy. In 1951 the company changed its name to Texas Instruments, GSI becoming a wholly owned subsidiary of the new company. An early success story for TI-GSI came in 1965 when GSI was able to monitor the Soviet Union's underground nuclear weapons testing under the Ocean in Vela uniform, a subset of Project Vela, to verify compliance of the Partial Nuclear Test Ban Treaty. Texas Instruments also continued to manufacture equipment for use in the seismic industry, and GSI continued to provide seismic services. After selling GSI, TI finally sold the company to Halliburton in 1988, at which point GSI ceased to exist as a separate entity. Defense electronics. Texas Instruments entered the defense electronics markets in 1942 with submarine detection equipment, based on the seismic exploration technology previously developed for the oil industry. The division responsible for these products was known at different points in time as the Laboratory and Manufacturing Division, the Apparatus Division, the Equipment Group and the Defense Systems and Electronics Group. During the early 80s, Texas Instruments instituted a quality program which included urine training, as well as promoting statistical process control, Taguchi methods and design for Six Sigma. In the late 80s, the company, along with Eastman Kodak and Allied Signal, began involvement with Motorola, institutionalizing Motorola's Six Sigma methodology. Motorola, who originally developed the Six Sigma methodology, began this work in 1982. In 1992, the DSEG division of Texas Instruments quality improvement efforts were awarded by winning the Malcolm Baldrige National Quality Award for Manufacturing. The following are some of the major programs of the former TI Defense Group. Infrared and radar systems. TI developed the AAA-4 infrared search and track in the late 50s and early 60s for the F-4B Phantom for passive scanning of jet engine emissions, but possessed limited capabilities and was eliminated on F-4Ds and later models. In 1956, TI began research on infrared technology that led to several line scanner contracts, and with the addition of a second scan mirror, the invention of the first forward-looking infrared in 1963, with production beginning in 1966. In 1972, TI invented the common module FLIR concept, greatly reducing cost and allowing reuse of common components. TI went on to produce side-looking radar systems, the first terrain-following radar and surveillance radar systems for both the military and FAA. TI demonstrated the first solid-state radar called molecular electronics for radar applications. In 1976, TI developed a microwave landing system prototype. In 1984, TI developed the first inverse synthetic aperture radar. The first single-chip gallium arsenide radar module was developed. In 1991, the military microwave integrated circuit program was initiated, a joint effort with Raytheon. Missiles and laser-guided bombs. In 1961, TI won the guidance and control system contract for the Defense Suppression AGM-45 Shrike anti-radiation missile. This led later to the prime on the high-speed anti-radiation missile development contract in 1974 and production in 1981. In 1964, TI began development of the first laser guidance system for precision-guided munitions, leading to the Paveway series of laser-guided bombs. The first LGB was the Bolt 117. In 1969, TI won the Harpoon Seeker contract. In 1986, TI won the Army FGM-148 Javelin Fire and Forget man-portable anti-tank guided missile in a joint venture with Martin Marietta. In 1991, TI was awarded the contract for the AGM-154 Joint Standoff Weapon. Military computers. Because of TI's research and development of military temperature range transistors and integrated circuits, TI won contracts for the first IC-based computer for the U.S. Air Force in 1961 and for ICs for the Minuteman missile the following year. In 1968, TI developed the Data Systems for Mariner program. In 1991, TI won the F-22 radar and computer development contract. Divestiture to Raytheon. As the defense industry consolidated, TI sold its defense business to Raytheon in 1997 for $2.95 billion. The Department of Justice required that Raytheon divest the TI monolithic microwave integrated circuit operations after closing the transaction. The TI-MMIC business accounted for less than $40 million in 1996 revenues, or roughly 2% of the $1.8 billion in total TI defense revenues was sold to TRI Quint Semiconductor, Incorporated. Raytheon retained its own existing MMIC capabilities and has the right to license TI's MMIC technology for use in future product applications from TRI Quint. Shortly after Raytheon acquired TI-DSEG, Raytheon then acquired Hughes Aircraft from General Motors. Raytheon then owned TI's mercury-cadmium telluride detector business and infrared systems group. In California, it also had Hughes infrared detector and an IR systems business. When again the U.S. government forced Raytheon to divest itself of a duplicate capability, the company kept the TI-IR systems business and the Hughes detector business. As a result of these acquisitions, these former arch-rivals of TI Systems and Hughes Detectors worked together. Immediately after acquisition, DSEG was known as Raytheon TI Systems. It is now fully integrated into Raytheon and this designation no longer exists. Semiconductors. Early in 1952, Texas Instruments purchased a patent license to produce transistors from Western Electric Company, the manufacturing arm of AT&T, for $25,000, beginning production by the end of the year. On January 1, 1953, Haggerty brought Gordon Teal to the company as a research director. Gordon brought with him his expertise in growing semiconductor crystals. Teal's first assignment was to organize what became TI's Central Research Laboratories, which Teal based on his prior experience at Bell Labs. Among his new hires was Willis Adcock, who joined TI early in 1953. Adcock, who like Teal was a physical chemist, began leading a small research group focused on the task of fabricating ground-junction silicon single-crystal small-signal transistors. Adcock later became the first TI Principal Fellow. First Silicon Transistor and Integrated Circuits. On January 26, 1954, M. Tannenbaum et al. At Bell Labs created the first workable silicon transistor. This work was reported in the spring of 1954 at the IRE off-the-record conference on solid-state devices and later published in the Journal of Applied Physics, 26, 686 Euro 691, 1955. Working independently in April 1954, Gordon Teal at TI created the first commercial silicon transistor and tested it on April 14, 1954. On May 10, 1954 at the Institute of Radio Engineers National Conference on Airborne Electronics, in Dayton, Ohio. Teal also presented a paper, Some Recent Developments in Silicon and Germanium Materials and Devices, at this conference. In 1954, Texas Instruments designed and manufactured the first transistor radio. The Regency Trail 1 used germanium transistors, as silicon transistors were much more expensive at the time. This was an effort by Haggerty to increase market demand for transistors. Jack Kilby, an employee at TI's Central Research Labs, invented the integrated circuit in 1958. Kilby recorded his initial ideas concerning the integrated circuit in July 1958 and successfully demonstrated the world's first working integrated circuit on September 12, 1958. 6 months later, Robert Noyce of Fairchild Semiconductor independently developed the integrated circuit with integrated interconnect, and is also considered an inventor of the integrated circuit. Kilby won the 2000 Nobel Prize in Physics for his part of the invention of the integrated circuit. Noyce's chip, made at Fairchild, was made of silicon, while Kilby's chip was made of germanium. In 2008, TI named its new development laboratory Kilby Labs after Jack Kilby. In 2011, Intel, Samsung, LG, Street Ericsson, Huawei's HiSilicon Technologies subsidiary, Via Telecom and 3 other undisclosed chip makers licensed the C2C link specification developed by Arteris Incorporated and Texas Instruments. Standard TTL. The 7400 series of transistor logic chips, developed by Texas Instruments in the 1960s, popularized the use of integrated circuits in computer logic. The military-grade version of this was the 5400 series. Microprocessor. Texas Instruments invented the handheld calculator in 1967 and the single-chip microcomputer in 1971, was assigned the first patent on a single-chip microprocessor on September 4, 1973. This was disputed by Gilbert Hyatt, formerly of the Microcomputer Company, in August 1990 when he was awarded a patent superseding TI's. This was overturned on June 19, 1996 in favor of TI. First speech synthesis chip. In 1978, Texas Instruments introduced the first single-chip LPC speech synthesizer. In 1976 TI began a feasibility study memory-intensive applications for bubble memory then being developed. They soon focused on speech applications. This resulted in the development of the TMC-0281 chip linear predictive coding speech synthesizer, which was the first time a single silicon chip had electronically replicated the human voice. This was used in several TI commercial products beginning with Speak and Spell, which was introduced at the Summer Consumer Electronics Show in June 1978. In 2001 TI left the speech synthesis business, selling it to Sensory Incorporated of Santa Clara, California. Consumer Electronics and Computers. In May 1954, Texas Instruments designed and built a prototype of the world's first transistor radio, and, through a partnership with Industrial Development Engineering Associates of Indianapolis, Indiana, the 100% solid-state radio was sold to the public beginning in November of that year. TI continued to be active in the consumer electronics market through the 1970s and 1980s. Early on, this also included two digital clock models. One for desk, and the other a bedside alarm. From this sprang what became the Time Products division, which made LED watches. Though these LED watches enjoyed early commercial success thanks to excellent quality, it was short-lived due to poor battery life. LEDs were replaced with LCD watches for a short time, but these could not compete because of styling issues, excessive makes and models, and price points. The watches were manufactured in Dallas and then Lubbock, Texas. In 1978, Texas Instruments introduced the first single-chip speech synthesizer, and incorporated it in a product called Speak and Spell, which was later immortalized in the movie E.T. The Extraterrestrial. Several spin-offs, such as the Speak and Read and Speak and Math, were introduced soon thereafter. In 1979, TI entered the home computer market with the TI-99/4, a competitor to such entries as the Apple II, Tandy Radio Shack TRS-80 and the later Atari 400/800 series and Commodore VIC-20. It discontinued the TI-99/A, the sequel to the 99/4, in late 1983 amidst an intense price war waged primarily against Commodore. At the 1983 Winter CES, TI showed models 99/2 and the Compact Computer 40, the latter aimed at professional users. The TI Professional ultimately joined the ranks of the many unsuccessful DOS and x86 Bacida Euro, but non-compatible Euro competitors to the IBM PC. The company for years successfully made and sold PC-compatible laptops before withdrawing from the market and selling its product line to Acer in 1997. Artificial intelligence. Texas Instruments was active in the 1980s in the area of artificial intelligence. In addition to ongoing developments in speech and signal processing and recognition, it developed and sold the Explorer computer family of Lisp machines. For the Explorer, a special 32-bit Lisp microprocessor was developed, which was used in the Explorer 2 and the TI Micro Explorer. AI application software developed by TI for the Explorer included the Gate Assignment System for United Airlines, described as an artificial intelligence program that captures the combined experience and knowledge of a half-dozen United operations experts. In software for the PC, they introduced Personal Consultant, a rule-based expert system development tool and runtime engine, followed by Personal Consultant Plus written in the Lisp-like language from MIT known as Scheme, and the Natural Language Menu System NLMENU. Sensors and controls. Texas Instruments was a major OEM of sensor, control, protection, and RFID products for the automotive, appliance, aircraft, and other industries. The S&C division was headquartered in Attleboro, Massachusetts. In 2006, Bain Capital LLC, a private equity firm, purchased the Sensors and Controls division for $3.0 billion in cash. The RFID portion of the division remained part of TI, transferring to the Application-Specific Products business unit of the Semiconductor division, with the newly formed independent company based in Attleboro taking the name Sensata Technologies. Software: TI sold its software division to Sterling Software in 1997. It is now part of Computer Associates. TI still owns small pieces of software though, such as the software for calculators like TI Interactive. TI also creates a significant amount of target software for its digital signal processors, along with host-based tools for creating DSP applications. Company divisions: today, TI is made up of 3 divisions: Semiconductors, Educational Technology, and Digital Light Processing. Semiconductors: semiconductor products account for approximately 96% of TI's revenues. TI's semiconductor-related product areas include digital signal processors in the TMS-320 series, high-speed digital-to-analog and analog-to-digital converters, power management solutions, and high-performance analog circuits. TI Euro unregistered trademark S Wireless business unit produces wireless solutions for products such as smartphones and e-books, tablets, consumer electronics and other portable devices. Wireless communications has been a primary focus for TI, with around 50% of all cellular phones sold worldwide containing TI chips. The Mixed Signal Automotive Group is a business unit that manufactures mixed signal and analog solutions for transportation and automotive applications. In the power space, this unit produces DC-DC controllers and converters, LDOs, voltage references and voltage supervisors. In the networking space, MSA has solutions for CAN and LIN. Safety-related solutions include airbags and anti-lock braking. Signal processing: digital light processing is a trademark under which Texas Instruments sells technology regarding TVs, video projectors and digital cinema. On February 2, 2000, Philippe Binant, technical manager of digital cinema project at Gaumont in France, realized the first digital cinema projection in Europe with the DLP cinema technology developed by TI. Another business unit of the Semiconductor division called Application-Specific Products develops specific products that cater to a broad range of DSP applications, such as digital still cameras, cable modems, voice-over IP, streaming media, speech compression and recognition, wireless LAN and gateway products, and RFID. TI makes a broad range of digital signal processors and a suite of tools called EXPRESS-DSP, used to develop applications on these chips. Microcontrollers and processors: Texas Instruments maintains several lines of processors, including the Satara ARM processor family featuring ARM Cortex-A8 and ARM9 to serve a broad base of applications. Texas Instruments also offers a portfolio of microcontrollers, including MSP430, low cost, low power consumption, and general-purpose 16-bit MCU for use in embedded applications, TMS-320C2XXX, 16 and 32-bit MCU family optimized for real-time control applications. C24X, 16-bit, fixed point, 20 to 40 MHz, C28X, 32-bit, fixed or floating point, 100 to 150 MHz. Solaris ARM Cortex-M3 based 32-bit MCU family, Hercules, transportation and industrial safety MCUs based on the Cortex-R4F and Cortex-M3. In the past, TI has also sold microcontrollers based on ARM7 and 8051 cores. In addition to its microcontrollers, Texas Instruments also produces several multi-core processor lines. OMAP systems on chips are designed for low-powered applications, and originally targeted mobile phones. As a rule, they contain an ARM application processor, a DSP, and sometimes other cores. Da Vinci SoCs contain a C64 series DSP core, an ARM9 core for applications processing, and specialized video processing peripherals. Ducati, see Texas Instruments. Ducati, Tiva C Launchpad, inexpensive self-contained, single-board microcontroller, about the size of a credit card but featuring an ARM Cortex-M4 32-bit microcontroller at 80 MHz. Competitors, TI has always been among the top 10 of the semiconductor sales leaders. In 2005, TI was number 3, after Intel and Samsung, and ahead of Toshiba and ST Microelectronics. For more information, refer to the semiconductor sales leaders by year. Some of its main competitors include Microchip Technology, Cypress Semiconductor, Integrated Device Technology, Qualcomm, Samsung Electronics, and Xilinx. TI has the largest market share in the analog semiconductor industry, which is an estimated market TAM exceeding $37 billion. TI is reported to have 14% of the market, leading ahead of competitors Saint Microelectronics, Infineon and NXP Semiconductors according to latest reports from Gartner. Educational technology, Texas Instruments produces a range of calculators, with the TI-30 being one of the most popular early calculators. TI has also developed a line of graphing calculators, the first being the TI-81, and most popular being the TI-83 Plus. There are many TI calculators still selling without graphing capabilities. The TI-30 has been replaced by the TI-30X. There are some financial calculators for sale on the TI website. In 2007, TI released the TI-NSPIRE family of calculators, as well as computer software that has similar capabilities to the calculators. Texas Instruments calculator community. In the 1990s, with the advent of TI's graphing calculator series, programming became popular among some students. The TI-8X series of calculators came with a built-in basic interpreter, through which simple programs could be created. The TI-85 was the first TI calculator to allow assembly programming, and the TI-83 was the first in the series to receive native assembly. While the earlier basic programs were relatively simple applications or small games, the modern assembly-based programs rival what one might find on a Game Boy or PDA. Around the same time that these programs were first being written, personal web pages were becoming popular, and programmers began creating websites to host their work, along with tutorials and other calculator-relevant information. This led to the formation of TI calculator web rings and eventually a few large communities, including the now-defunct TI Files and still active TICalc.org. The TI community reached the height of its popularity in the early 2000s, with new websites and programming groups being started almost daily. In fact, the aforementioned community sites were exploding with activity, with close to 100 programs being uploaded daily by users of the sites. There was also a competition between both sites to be the top site in the community, which helped increase interest and activity in the community. One of the common unifying forces that has united the community over the years has been the rather contentious relationship with Texas Instruments regarding control over its graphing calculators. TI graphing calculators generally fall into two distinct groups, those powered by the Zilog Z80 and those running on the Motorola 68000 series. Both lines of calculators are locked by TI with checks in the hardware and through the signing of software to disable use of custom flash applications and operating systems. However, users employed brute force to find the keys and published them in 2009. TI responded by sending invalid DMCA takedown notices, causing the Texas Instruments signing key controversy. Enthusiasts had already been creating their own operating systems before the finding of the keys, which could be installed with other methods. Industry recognition. In 2007, Texas Instruments was awarded the Manufacturer of the Year for Global Supply Chain Excellence by World Trade magazine. In 6 consecutive years, TI made it to the list of most ethical companies in the world, compiled by Ethisphere Institute. TI is the only company to appear for 5 consecutive years in the electronics semiconductor category. A more complete list of TI's awards and recognition can be found at the Texas Instruments website. Acquisitions. In 1997, TI acquired Amati Communications for $395 million. In 1998, TI acquired DSP. In 1999, TI acquired Libit Signal Processing Limited of Herzliya, Israel for approximately $365 million in cash. In 1999, TI acquired Butterfly VLSI, Limited for approximately $50 million. In 1999, TI acquired Tology Networks for $457 million. In 1999, TI acquired Unitrode Corporation. In 2000, TI acquired Burr Brown Corporation for $7.6 billion. In 2006, TI acquired Shipcon for approximately $200 million. In 2009, TI acquired Luminary Micro. In 2011, TI acquired National Semiconductor for $6.5 billion. National Semiconductor acquisition. On April 4, 2011, Texas Instruments announced that it has agreed to buy National Semiconductor for $6.5 billion in cash. Texas Instruments will pay $25 per share of National Semiconductor stock. This is an 80% premium over the share price of $14.07 as of April 4, 2011 close. The deal made Texas Instruments the world's largest maker of analog technology components. The companies formally merged on September 23, 2011. Corporate governance. Restatement. On August 6, 1999, Texas Instruments Incorporated announced the restatement of its results for parts of 1998 and the first quarter of 1999 after a review by the Securities and Exchange Commission over the timing of charges for a plant closing and write-down. See also: Analyte Technology, TIASC, TI 990, TI Basic, Calculators, N-Ocean, Symbian, OMAP. References, Notes. Citations. Bibliography: Sweetman, Bill and Bonds, Ray. The Great Book of Modern Warplanes. New York, New York, Crown Publishers, 1987. ISBN 0-517-63367-1. Further reading: P. Bynant, Aucur de la Projection Numa. Copyright Rick, Actions, 29, 12 €13, Kodak, Paris, 2007. Tia Reid, The Chipper: How Two Americans Invented the Microchip and Launched a Revolution, Random House Trade Paperbacks, New York, 2001. Nobel Lectures, World Scientific Publishing Company, Singapore, 2000. External links: Official website. Texas Instruments Records digital collection contains hundreds of photographic images and documents from the Texas Instruments Records archive held by SMU unregistered trademark S. de Gallia Library and/or TI Headquarters. Each item includes information about its relationship to Texas Instruments unregistered trademark corporate and technological history.